Alec, go ahead.
Alrighty. So hi everyone, welcome to our mini Kaizen. My name is Alec Jacquelina. I am a San Jose student majoring in industrial systems engineering, and I will be an upcoming senior this year. So our mini Kaizen is standardizing and automating specialty door fabrication, and my team is Steve, Miguel, and Hector. Next slide, please.
Okay, so go ahead and yourself. Steve, you're gonna. Oh, sorry, that's me.
All right. Can you guys hear me without the echo now?
Yeah.
All right. The story of our Kaizen, why it was needed. Only one fabricator is trained on the Fadal. No standard for production materials. A lot of additional labor for manual layout and operation of the Fadal. And the current process has some safety concerns. Okay, for our scope sheet, our problem statement is there is no standard process for control on how specialty fabrication is done on auto headers and ESK strike cutouts. And just so everybody understands, because of the short timeline we had on this this Kaizen event, we decided to pick one specific item, get the process on that item figured out, and so we can take that process and use it on other parts, so that it'll be, you know, it's something we can just add other parts into, and it'll follow the exact same process. And then our goals and objectives, because of the problem state or the current situation is just what we pretty much read out earlier. So the goals and objectives: to create a standard process on how to fabricate, or how fabrication is done on auto headers, automate all fabrications on the Fadal and move some of the processes to the Diamant, standardize a process for miscellaneous materials, take control over buyout products with Walters & Wolff Interiors in regards to sizing and layout, and teach multiple door department personnel how to run the Fadal. Next slide.
All right, so moving on, this is our current state map. And so our current process right now is that we would create a shop work order. Then we'll be handing that over to our door guy, Gabriel. Then once that's done, we would then get a auto header. And during that time, we would then measure to see if it's the correct size. Then Gabriel would then determine any miscellaneous material that's available that is be able to be fabricated. And then Gabriel would then draw the layout onto the auto header. Then he'll start cutting on the Fadal. He then verifies the parts that would fit into the cutout. And then he would fabricate any like backup plates, mounting brackets that needs to be installed onto the auto header. And so with this current state process though, we do run into some problems, and some of the main ones are there's only one person that knows that's trained on the Fadal. There's no standard on what material is available for the auto header, and it does take some time to manually cut out the layout. And when he does cut out the layout, the doors are open on the Fadal, which raises safety concerns. Next slide, please. Yeah, so this is our future state map. We will still be creating a shop work order. Then from there, we would then have a door clerk verify the door dimensions, the auto header dimensions. And they would create a Fab ticket for the auto headers, give that Fab ticket to the door department, and the door department will then use the pre-established program and verify that the part fits into the cutout. And after that, if it is an anodized part, then it will be assembled and sent to the field. But if it's a mill part, it will be packaged and sent to paint. Next slide.
I'm sorry, that's me.
Yeah.
That's our current fab ticket for the auto headers that we've come up with for the basic fabrication. And as you can see, it calls out the job, the door number, the shop work order number, and then it has some specific questions that we have to answer so we know where the layout's going to be, how it's going to be done. And then basically for the fabrication, we're going to have program numbers, and they'll be called out on the ticket so that when the guys in the door department will just be able to take the USB drive, plug it into the machine, enter in the program number they're going to use, and then it'll automatically run it. They won't have to sit there and do like manual layout or anything. It should all be pre-established.
This is the first SOP that we created. It's for the general setup of the Fadal. It just tells the guys what they need to do in order to turn on the Fadal. Like, probably the most important part is checking that the Fadal has enough oil and that it does like its initial calibration correctly. The next SOP we created was a e-offset SOP. The e-offset is used to tell the program where the origin is, where it will start machining from. It tells it there's a 0 point for the X and Y and Z. From that point on, once you create your e-offset, the machine will just pretty much do everything for you based off what you have on the program. And then the next one we created was the tool calibration SOP for the Fadal. So every time you're gonna run a new program, you always need to calibrate your tools just to make sure everything's like up to date with whatever's on the spindle. Because you never know if a tool got broken or somebody switched out a tool and didn't recalibrate it. It's just kind of prevents that error happening.
On this SOP demonstrates how to properly replace a tool when it breaks or if it's so. It tells you how to properly replace it. The next SOP, for down shutdown SOP, it tells you how to correctly home the machine because if we don't do that, once you start it again, it'll lead you a lot of errors.
Okay, so here is the time lapse of the cutout. So for the component that we decided to test is an electric strike 2 standard. And so here's a time lapse of that. And it would take our door guy about, I'll say an hour and a half to do this cutout. But when I took this time lapse, I've actually did a regular video and it took about 7 minutes and 30 seconds. And so some of the pictures here, the first one that you see is the final product of the cutout. And the last 2 photos is of just me verifying that the part fits into the cutout. Next slide. So yeah, here's our open items. As Steve was just mentioning, that this is because internship, we did just want to focus on one component and to determine the process. But once this mini Kaizen is completed and we have this process finalized, we would like to automate other components along with different types of auto headers. We also would like to include the Diamant machine into the automation process. And this is because the Fadal could only take up to 8 feet and the Diamant could handle a full stock length. Any questions?
So how many different types of hardware? I mean, when you talk about these auto door headers, is it a lot of variation or is it like, 10 or 12 different things we do a lot of? How does it look?
I think the biggest variation is like, if it's a glass door, it's going to have a different ESK strike. It's going to have the ESK2. The one that we ran was the ESK2 SD, which is for the style doors. Then there's the ESK1 strikes. And we want to get all the strikes, all the Von Duprin cutouts. If say the auto header only has an auto motor on one side on a pair and a manual closer on the other, we're going to have it so it does the fab for the manual closer for the cover plates and all that stuff. Any type of additional, like if it has, say, a Glenn Johnson overhead stop, we want all that stuff automated. That's our goal, is to have everything automated so that there is no manual hand cutting of the parts in the door department. And a lot of this stuff we will be able to move over to the Diamant, but it's nice to have the Fidal as a backup in case the Diamant's overbooked or something like that.
I like the fact that it's safer, because I have seen Gabriel manually machining headers back there with the doors open, right, and exposes them to a lot of chips and different debris flying around too. So that's important, because safety is the most important of all.
Yeah, let alone breaking a tool or something, right?
Yeah.
Would there possibly, you talked about calibrating because the tools may have changed, change tools or what have you on the tools holders. I think a potential here would be to standardize the tooling and the setting of those tools like we do on the Diamant, Planet, and the Quadra. Is that something that you considered? I know it was something that Hector had worked on.
That's something we can do over there. But the Fidal works the same way as the multicam. So that it's better for you to calibrate your tools every time you want to use the machine to prevent any accidents.
Got it.
That will be the same principle.
Yeah, and the one thing I would add, just as you're thinking about it, we've had a lot of situations in the company where, we have something like this where we want to get set up. And so we build a library of things, to be ready for. But what we found over the years is you're better off just to do the things as they happen. You're going to need to program them when they come up. But as long as you have a system where every time you program something, it goes into your system so that anytime it comes up in the future, you're done, you're better off. Because we had, entire libraries of things, and only 20% of it sometimes ever gets used, because the things you think of in your head that could happen aren't always the things that really, jobs are much different than we think. It's like, oh, we always have these. And, sometimes it takes 2 years to get to that, right? So sometimes the best thing is just to have a good process where each time you use it, that goes into a library and that gets done. And it's just an extra step, but you build your library based on what's really happening rather than what you think would happen,
Yeah, and one of the things with the e-offsets is that once we have one established for, say, like the LCN 5800 auto header, once we have that e-offset established and we designate a number on the machine for it, like say 17 or 13, that will always be the e-offset for that header. So we shouldn't have to always go back and recalibrate the machine for the e-offset. And once the program is written, we can actually establish the e-offset in the program so that the operator doesn't manually have to set it. It'll be in the program.
So I know the e-offsets have been a bane of Miguel's existence for a while, but like, is there not just a common 000 or something somewhere that you could just make the same e-offset consistent for every part?
So that depends on where you place your part. So because we're putting all the e-offsets, we're putting all the auto headers like in the back of the Fidal, leaning to at the same stop. At one point, we will have the same e-offset. We just change the offsets depending if the auto header size is different. So
it all, because it has to have an origin point where it's starting from.
Mm-hmm.
And because there's just so many different, we got 4.5 by 5 3/4 headers, we got 4.5 by 6-inch headers, we got 2 by 2.5, there's just so many different variations. As long as, because I'm not exactly sure what the number are, but I think it's like 30 something or 40 something e-offsets we can have pre-programmed, and those will be pre-programmed based off the material, not off the fabrication, but off what material are we using, and that e-offset will be designated for that material. Like, is it a 600 420? Is it a 500 420? That it'll have a specific e-offset for that part.
any more questions?
Nope.
All right. Last but least. All right.
Want wanna go first, Steve?
Yeah, I'll go first. Yeah, so I really felt that this was something I wanted to tackle for a long time, because I've physically been over there watching this process happen on the Fadal, and I knew we could do a lot better. And I think as we implement this and get everybody fully trained on, we won't be stuck with just one person running it. I think it's going to be immensely a big difference that we see, because the possibilities of errors will go down dramatically, because once we have we have the cutouts pre-established. Once we know it works, as long as everything's set up right, it shouldn't be a problem. And all that programming will be done here. All they'll have to do is plug in a USB drive into the machine. And so, yeah, I'm really happy with where we've gone just with this first part.
Cool.
Hector?
Well, I think it's nice to have the programs ready on the Fadal as well as in the DMN. And like 95% of the door fabrication now, it's been done either on the DMN or Quadra. And this was one of the last components that we needed to tackle. So the only thing preventing me from doing that on the DMN before was that I didn't have the files for the outer headers. Well, now we're getting those files, and we'll have all those programs ready on the DMN as well. So yeah, it's good. And also, like Steve was saying, we're gonna take more control over how the auto headers are ordered. Many of the times it will be wrong, and many of the labor will be trying to fix those errors from the door headers being ordered wrong on the wrong side. And even the fabrication from the manufacturer was wrong, so we have to redo them, and it was even more labor. So it's good that we're gonna have control of that in the future.
I really liked how through this Kaizen, we'll be able to have more control over the tools that are in the spindle. Because since Gabriel does a lot of the manual fabricating, he has like half the tools and I use the other half. So whenever I need to add more tools, a lot of times I would have to either remove some of my current existing tools I was using, or I would have to just swap them in and out. But now with this, I'll have be able to standardize what tools are being used in the spindle, which I really liked. Alec?
All right. Hi, everyone. What I liked about this Kaizen a lot is just that I was able to automate the cutout, and man, it taking about like an hour and a half could definitely take a long time. So just to see that I was able to produce something like around under 8 minutes, I really enjoyed that. It saves a lot of time since I am an industrial and systems engineering major. Finding waste to cut out is huge. But moving forward to just talking about my whole experience here at Walters and Wolff, this internship, it means a lot to me, because I've known there's other students who've been struggling to find something, especially during this interesting time that we're going through. So I'm just very grateful for this position being opened and allowing my amazing 3 managers for just working with me. I've definitely made my fair share though of mistakes during this process, but through their guidance and their help and their work ethic and the culture of the company, they've allowed me to fall forward. Rather than making me feel like, oh, well, you didn't do this or this, but they've been really patient with me. And that's been something that I was nervous about, because I've always been told that, oh yeah, the work culture is like super important. And I didn't see how much of a difference that is until I got to actually work here. And I've learned a lot. Like, being an industrial and systems engineering major, I'm not someone who gets to be really hands-on. So coming here and having Miguel teach me how even the tools, like when they meet the part, like it could melt. I had no idea about that, but through his guidance, he's definitely been helping me with that, and learning how to run the Fadal machine. I was so intimidated at first, but he's been really helpful with that as well, and being super patient with me on Inventor. I mean, I've learned how to use Inventor. I'm still getting used to the AutoCAD, and I mean, I got to 3D print stuff here, and it's just been an amazing and such a blessing to just have this opportunity. So I just want to say thank you all for just taking this chance and giving me this opportunity. Thank you.
Oh, we're very glad to have you, Alec. It helps us all learn new stuff. So it's a great experience for everybody.
Thank you.
All right, so now next up is going to be Anna. I'm going to stop sharing for a second. And,